actually recording this whole thing, and I'm going to present it online on like you for YouTube or something, and that way this is like saved, if you will, and or recorded, so people can watch it. I guess you could say at their leisure, because I know because nobody listened to me when I begged them to please not join till 11:05, and I was, not able to join because this is the free version of Google Meet because, of course, nobody thinks to ever allow teachers to get paid for the subscription of the good version of Google Meet. Because of that, if I don't join first, I'm not the host, even though I created the meeting. I mean, that Google Meet invitation, the original, the one that's in the syllabus, that's like 2 years old by now. And even though I created it, I'm not the. It's like peer to peer, in which whoever clicks on it first is the host. And then when I try to join, if somebody already clicked on it first, they have to allow me to join. And so, anyways, is anyone here from the class that is just online? Anyone here from, what is the online section, 40 or 39? What section meets in at Eastern? 39?
Or 39.
39, okay. Is there anyone here from section 40? No one here is from section 40? Oh, wait a minute. Let's see. In-call messages, no. No one here is from section 40. Okay. Looks like most people that I see here are from section 39. Let me just see. So I did put everything, I did promote to everyone to section.
I don't know if I can hear you anymore.
Okay, 1 second. Okay. So no one, can you hear me now? Can you hear me now?
I personally can. It never cut off.
Okay, let's see.
Professor, I've been able to hear you the entire time so far.
You haven't, or you have?
No, I've been able to hear you perfectly the entire time.
Okay. Let's see. So no one's here from section 40. Okay. Well, that's the beauty of Mike McCarthy. Mike McCarthy. Aren't you supposed to be coaching the Dallas Cowboys? No, I'm just kidding. I think you were Mike. The real Mike McCarthy was fired from that job. I actually like Mike McCarthy. Anyways, okay. Let's get things going, because this will be recorded, so everyone in both sections will ultimately be able to see this. I'd like to start today. I made some changes to the syllabus, by the way, mostly having to deal with the topics. So feel free to peruse that at your leisure. We went over the syllabus the other day, so we're not going to do that right now. And just so you know, if I'm a little distracted, just because the way Google Meets works is that every singular time somebody joins, I have to admit them, because I'm just using the free version, and this will cut off at noon sharp. So we have to get through a lot of stuff. So please keep the questions to a minimum. I'd like to start off with the OSI model really quickly. We're going to talk about the OSI model in depth on Tuesday, but here's the basics of the OSI model. It is 7 layers. The top layer is the application layer. So the application layer is basically the start of the request, and it controls what the, I'm going to say, packet looks like, if that makes sense. So for example, let me put the laptop down here. And for example, when you want to create, when you go to a web page, for example, the type of request on layer 7 is called an HTTP request. Okay, so that allows you to, as the source, as the requestor, that allows you to ask a web server for their web page. Okay, so that begins on layer 7. Layer 6 right here is the presentation layer. Okay, so if layer 7, the application layer, determines the type of request or whatever, the presentation layer dictates the format of the request. Format. So an example of this is how many of you have ever been denied? Well, this is not going to be applicable today because every laptop comes with an adapter that can pretty much connect to anything. But there was a time, believe it or not, when if you bought a laptop, it wasn't even by default able to connect to a wireless network. You actually had to purchase an external adapter, whether it was a dongle cable or whether it was a USB style adapter. You actually had to purchase an adapter, and then you had to figure out, what type of network you were going into. Back then, there was 802.11a, 802.11b, 802.11n, and so if your adapter was not recent enough to join 802.11n, for example, and you only could join 802.11g, for example, even though you had the right password or Wi-Fi key, the type of the format of that 802.11 adapter could not, if that format could not understand 802.11n, okay, because the formats were different, you were not allowed into that network because the encryption standards and all the standards of 802.11n are different than 802.11g or 802.11b. Now, it goes back. I don't want to go too far into the weeds. This is just an example. We're just talking about format right here. It's kind of like, for example, if you let's see, we've all programmed in C++ or Java or I was going to say Pascal, Python. So as an example, can you fit in? You can fit an int into a double or a float, because all a double or float is the integer part and then the decimal part after that. But can you take a double or a float and put it into an integer? The answer is no, because you're missing the decimal part. So we're dealing with formats right here. So even though the Wi-Fi adapter, you may have a Wi-Fi adapter, but if it's 802.11a, for example, it cannot communicate or, shall I say, liaison or talk to a access point that only allows 802.11ac or 802.11n. Actually, I use 802.11g and 802.11b before my examples, but actually 802.11n is backwards compatible with G and 802.11b. But 802.11a, one of the first standards out there, does not correspond with n. So that's just an example. Presentation is nothing more than formatting. Session deals with making connections. So where the session layer is important is, for example, print servers. Print servers have to respond, so you're only having one. A lot of times you have one printer versus many clients, sometimes 100 clients. So that print server has to deal with not only every connection, but seemingly I'm going to say multiple simultaneous connections. So that's what the session layer allows network connected devices to do, is to manage connections, even to the point where they're seemingly simultaneous. And they do this with a cache. And another example of sessions is probably SQL databases, because SQL databases, a lot of times, they're global. So they're literally responding to many connections across the globe, seemingly simultaneous. Look at Google, look at Amazon, any server that's out there, Facebook. Think of how many almost simultaneous connections they are dealing with. So that's the session. Transport layer, and again, this is just a bare bones introduction to the OSI model. And even though we're going to be talking about primarily Chapter 1 today, and OSI models Chapter 2, I want to begin to just talk about OSI in its bare bones framework. So transport layer can be divvied up into two flavors, if you will, TCP and UDP. And we'll talk more on Tuesday about the differences between TCP and UDP. The network protocol, the network layer. James? You seem to be pretty engaged right now. Can you tell me what information on the OSI model the network layer offers us?
I'm sorry, Professor, I do not know.
Okay. You're not supposed to know. You are not supposed to know, so that's good. That's okay. That's definitely acceptable. The network layer gives us layer 3 information. So the layer 3 information is the layer 3 addressing allows us to connect to nodes, or a node is defined as anything with an IP address. It allows us to communicate with devices that are outside of our local framework. So without the network layer, we couldn't get to Google. We couldn't get to Amazon. We could not get to any servers outside of our server room or outside of our local network. The data link layer, believe it or not, that is also other addressing. Well, what do you think the data link, what type of addressing do you think the data link layer gives us? Let's see, Chris? Well, how about Andre? Yeah, Andre the Giant Brooks. What do you think? What addressing do you think the data link layer gives us? Well, because it's already 11:17, we want to press, and I only have you guys till noon today, so. Data link gives us the MAC information, the MAC address, media access control address. So, before you're like, well, wait a second, network also gives us addressing. What addressing does a data link? So, well, what's the difference? Well, first off, the network address is essentially the IP address. So we're talking 192.168.1.1 as an example. The data link is usually presented in hexadecimal, so that refers to the actual physical address of the network interface card. So in the TCP IP realm of things, you need both for a network to communicate. Right now, I want you to think of it as when you're at a restaurant, like a family-style restaurant, and the waitress comes at you, and she says, "What do you want?" And you're like, "I'll take a cheeseburger." She's got to ask, what type of cheese? How do you want it cooked? What do you want with it? Do you want fries? Do you want coleslaw? And all that other stuff. So think of it like you just need, in every request out there known to man, you're going to need the IP address and the MAC address. MAC addresses are everywhere. For example, your cable box at home has a MAC address. And I don't know if it has an IP address, but it has a MAC address. Your TV, smart TV at home, has a MAC address. The thing I'm talking to you right now through, my MacBook. I have a MacBook, not necessarily a Windows laptop, because your instructor hates money. That's why he gets MacBooks. Anyways, that has a MAC address. It has nothing to do with the name of it being Mac, because that's short for Macintosh. So your car, if anyone has an entertainment center or GPS thing in your car, that itself has a MAC address. So everything is a MAC. The physical layer is self-explanatory. That is the actual, I'm going to say, media that is transferring the information. If it's right now, I'm connected via wireless, via my Wi-Fi signal going out to the gateway where I'm currently at. Actually, well, I don't want to tell you where I'm at. I'm actually, let's just say I'm at Eastern. Anyways, so it's going through the gateway and through a series of routers and other gateways, and finally, I'm ending up at your collective houses. So I'm connected through Wi-Fi, at least locally, until it gets to the ISPs, which is, I'm sure, fiber optic MPLS connections all over the place. And I'm using Wi-Fi. Wi-Fi uses radio waves, RF waves. If you're connected via an Ethernet cable, which some of you maybe are, okay, a friend of mine has a big gaming PC, gaming rig, and his Wi-Fi cut out on him. So he called me. He's like, "What do I do?" I said, "You just got to think of another way to connect." So I had him get an Ethernet cable, and he ran his Ethernet cable from the back of his gateway to his computer, and it's actually even working better. So you can use Ethernet as your connection, which is actually uses copper, right? And finally, you can use fiber optic cable, which uses anyone? D1 James? Which uses light. Just like James is gonna run with the ball like lightning. I'm just kidding. I don't know what position you're playing. You said you were on the defensive line or something? I don't know.
I play corner, yeah.
Oh, you play corner. Okay, you probably have a big old picture of Deion Sanders. Anyways, so that's the OSI model. And now that's chapter 2 stuff. And the reason why I just want to introduce that to you is because OSI is so important in networking and so important. You're literally, because you see how the OSI model is divvied up? Hold on, I have to admit this person. Do you see how OSI model is divvied up? Here, let me just, so we have here layer 7, 6, 5, 4, 3, 2, 1. So the reason why knowing OSI is important is we still talk about layer 3 technology, we still talk about layer 2 technology, and we talk about things communicating on layer 1. So the reason why is that when we talk about things communicating via layer 1, generally we're talking about a regeneration of connections of packets, so there's no change. Layer 2, we're talking about the packets as they parse the MAC addresses. And layer 3, we talk about how things parse layer 3. Layer 4, we talk about how does the packet look like? Because TCP and UDP have markedly different features to them and different pros and cons. And then the application presentation session generally are treated as one, but it's always making the creating of the request itself. This is where the user directly has, sorry, I should have been like this. This is where the user directly has input, the first 3 layers. So anyways, we'll talk more about that next time, but the reason why it's so important is if you literally did a Google search for layer 3 technologies, you would see something. So this is just industry standard. So if you cannot talk layer 3 or layer 2, then you cannot talk networking. And the point of this class would be moot. It's just a waste of your time. Okay, chapter 1, Introduction to Networks. So the idea is, what is a network? And your textbook or your workbook or whatever defines a network as a system of interrelated things. Now let's please, this is going to sound like grade school, but look at figure 1.1. We have here a basic network, and I'm on page 79. Wow, 79 already. a basic network. And I hope everyone goes to see it, and hopefully everyone got somehow for the book, but I couldn't find it. I'm going to I'm going to create a little how-to video this weekend about packet tracers, so don't worry about that right now. I mean, it's only week 1, so I mean, we have just a little bit of time, but I think we'll be okay. I think we're going to be fine. So we have here a network segment that you see, everyone sees figure 1.1, a network segment. So this means that host A can communicate to host B, but also I would hope that the resource here, now the resource generally it shows a printer, but typical, the whole reason why networks exist, man, I wish we had more time. I wish we had more time today. I really wish I did. But the reason why networks even exist, the original intention of networks existing is that they wanted to share engineering files, and Xerox wanted to share the world's first Xerox laser printer, believe it or not. The man that did this, his name was Robert Metcalf. And he's literally the world's first Geek Squad member out there, Best Buy Geek Squad. What Robert Metcalf did was he was at Xerox. He literally created the world's first laser printer. And he looked at something called AlohaNet. And he saw AlohaNet are these shortwave radios that they used in Hawaii at the time. And he said, and this is back in like late 70s, and Robert Metcalf at this time was like a PhD student. And he said to himself, and at the time they had ARPANET. Now ARPANET is the granddad of what we refer to as the internet. Now the internet is the world's largest wide area network. And without the internet and the internet technologies, okay, we could not be talking to you right now, okay? And certain things would cease to exist. For example, University of Phoenix, so with their big online presence, that wouldn't exist. A lot of people would say these universities would have shut down without the internet, because during COVID, everyone was forbidden to go to class. So I don't think their universities could have survived without the presence of long-distance education technologies, right? So the whole point, Robert Metcalf said, okay, ARPANET exists. Can I have the benefit of of ARPANET and these shortwave radios? And so he created the world's first Ethernet. So the world's first Ethernet was used to connect resources like print servers and file servers together. Now this connection right here is what we call a network hub. So this is what we call a network segment. A local area network is just as it says. It is a work group in which everyone is connected to each other. Okay, that's a LAN. Now a LAN is everyone in the same quote-unquote subnet. And before everyone panics about what subnets are, we're going to begin to speak about that next Tuesday and mostly next Thursday, or mostly 2 weeks from now. So don't worry about that. But a local area network is everyone basically in the same computer room. So for example, I'm in a room, okay? Let's say I'm in room 131, wink, wink, and everyone in there is in the same local area network because we're all in the same room and we're all in the same work group. Okay, I got to move on here. Here we have figure 1.2, 1.2, two separate LANs or two separate work groups. We have the sales networking segment and the marketing network segment. I'm on page 81. Hopefully everyone sees that. Now, I wish it would have labeled it a bit differently. we have the marketing resources on the right side. Does everyone see that? And then the sales on the other side. Okay, so my question is, let's say we had can a person can a computer connected to the sales networking segment, can they get to the sales resources? And for the purposes of time, because it's already 11:30, the answer is yes, obviously. Just like the marketing can get to its directly connected resources, right? But here's the problem. Can sales get to the marketing resources? And the answer is no, because and I'm asking you based on the topology there. The answer is no, simply because there's no connection. Okay. Now, in order for you to can make it so that sales can connect to the marketing resources, because they're in different work groups, thus they are in different subnets, you need to connect a router in between them, a layer 3 device, because a router understands layer 3 information, meaning IP. Now, sales can finally get to the marketing resources. Okay? I know I'm not going to give everyone very long to answer this question, but can somebody answer me this? What is the drawback of figure 1.3? On page 82. A drawback is the fact that because we have a router, that obviously the advantage is that the sales PC can connect to the marketing resources. The negative, the drawback, is that yes, we are going through a router. Routers tend to be, routing, because it's layer 3, tends to be slow. Tends to give us a lot of latency because there's a lot of change in conversion. The packet actually changes and metamorphosizes as it goes from one side of the router to the other side of the router. So there's a little bit of latency. We'll get to that later. Okay, common network components, workstations, servers, and hosts. A workstation is any PC, they should have said node there too, and I'm on the bottom of page 83. So another thing is node. So workstation, servers, and hosts. What do they all have in common? They're all nodes, right? They all have an IP address on the internet. The difference is a workstation can be a server or can be a client. Ali, come on, man. Where'd he get the book from? Come on. I'm not going to say it. Well, okay. Andre, you said you're lost. What is going on, buddy?
Like, where do I find the book as well?
You can buy it from Amazon.
Might as well do that. Come on, man.
I mean, there's a site called the Archive.
If you guys wanted to, James, you talk to each other, but I cannot,
Yeah, if you go on Ann's Archive, you could just type in the name of the book and download it. That's what I did.
Okay. So workstation, servers, and hosts, they all have IP addresses. They're all nodes. Workstations tend to be a beefy PC or oftentimes they're Unix. And I wish they also have these things called dumb terminals. A host can be a server or client. All right, I'm just going to move on. Let's go to Metro. Let's look at network types. And man, this hour, I'm serious. I'm serious when I say this hour's flying by. And I just want to get through chapter 1. So a metropolitan area network is a network covering a metropolitan area. And I don't like that they did that first. Let's talk about wide area networks. That's the more extreme of it. So here, let me just demonstrate what it is here. Hopefully, let me just tilt this so everyone can see. So a LAN, this is a LAN. So this is connected to various PCs. God, my writing is horrible. That's a LAN. And here we wanted to connect, here's another LAN. Here, so here's a switch 1, this is switch 2, and then we're connected to these PCs right here. So maybe this is east, and that's west. Okay, so that's LAN 1, and that's LAN 2. So we want to connect these LANs together. Okay, and we in order to connect them together, we need a router in between them. So this whole thing now is a WAN, wide area network. LAN is local area network, and this is wide area network. And this is what creates the wide area network. And this is an overly simplified view. What it really looks like is an impossibly infinite amount of routers in between, and they're all hooked together somehow. An example of the unreal breadth of WAN technology is there's a connection between Ashley in North Carolina and Chicago that actually carries 99.99% of the world's traffic. We're talking about Europe and Taiwan and China. Everything is going through that pipe because it literally is the most has the most bandwidth that there ever is. And so just to give you an idea of the amount of redundancy that is out there in the world. So when you think of this, which is why when we draw the internet, because nobody can keep track of everything, the internet is usually drawn like a cloud. And this is masked because nobody can keep track of it anyways.
I have a question.
Yes.
So basically, the WAN and LAN, like the LAN is just like a house or something short, and then
Yes.
WAD is like a big city or like a corporation that's far apart.
Well, yeah, kind of. So you're right. A LAN could be like your house. Now, think of your house. How many of you have Xfinity? Or what do you guys have? What do you guys have?
Xfinity.
Okay, Xfinity. Okay, so the connection. So let's say a lot of you have, a wireless. Xfinity gives you that wireless gateway, so everyone's walking around your house, in your basement, in your room, in the kitchen, in the play area, or in the entertainment area with different laptops. So yeah, you're all in the same local area network. You're connected essentially by a layer 2 switch. Once you get outside, that's where we begin to see WAN technology. And then finally, when you get connected to your ISP, your local ISP, and that connects to other backbones in the internet, okay, that begins the cobweb of routers that you're hopping to you get to your final destination. Maybe it's Amazon, or maybe it is Facebook or Alibaba. So wide-area network technologies connect LANs together. They include routers, gateways, and things like that. And metropolitan area network uses WAN technology. They use routers. They use MPLS connections. But as somebody said, they're actually connecting like an entire metropolitan city together. And we have here personal area network uses like Bluetooth. So you're talking a personal area network is like you connecting your cell phone to your car without the wire. Okay? What about on your desk? On your desk area, not your desktop, your desk area where you might be working, or whether or not you're in class in room 131, where I'm coming from now, wink, wink. Like, what else do you see anything on the desk that would also be a personal area network? Okay, I'm going to answer it. Sorry, I'm not giving anyone any time because it's already 11:40. An example is the Bluetooth mouse some people have. A lot of people don't want to connect their mouse to their PC. I still like the wire connections because I'm old school and I don't like all that possible interference. But a lot of people still like to connect the wire. But most people like the Wi-Fi. Well, the connection between your mouse and your little PC there, or your keyboard, is Bluetooth. And let's see. Campus area networks are kind of like, again, use routers, and sometimes they can use MPLS connections. I know at Eastern Michigan, to get from one building to another, you're of course going to use WAN technology, but there's a special designation for a campus like Eastern that connects everyone to each other, and they call it a campus area network. So that's when campuses use WAN technology to specifically connect a campus together, and that's what we call a campus area network. Storage area network are for data centers. Software-defined network is when a device, a device like Cisco's device here. One second. There's a special name to it. Zscaler, no, fully managed They bought a company that they bought Splunk. I can't believe that. I'm sorry, I cannot think of it. Let's see, July 210 Zane. I can't think of him. Here's a type of devices that actually define the network. So a software-defined network uses heuristics to determine the next path, and that's popular for like Mexico because Mexico is well known for bad connections. So if you are in let's say a Stellantis plant in Mexico, and all your connections go through Mexico's infrastructure, you're going to need SD-WAN, the device to select the best area to go to, because MPLS connections are notoriously bad. So you could be connecting from Mexico to the United States through cell phone towers or through local connections or whatever. So software-defined WAN uses heuristics, using like 20 different variables to determine the best path. MPLS, okay, it uses shims to determine the best path to go to. And MPLS networks generally run on fiber optic cables. So MPLS networks are really, really fast. Generally, MPLS networks can be used between data centers for redundancy. So, for example, the Stellantis, one of their data centers might be in Auburn Hills, The other one might be in Sterling Heights, SHAP. Sterling Heights on Van Dyke right there, the SHAP plant, Sterling Heights Assembly Plant, that stands for SHAP. That is their alternative data center. And there are like 5 or 6 redundant MPLS links between those data centers, and each link is managed by a different company. So you might have one link managed by CenturyLink, another link managed by AT&T, and another link managed by Verizon, okay? And they are all sent in parallel to ensure the highest possible throughput and to ensure all the data actually gets through. So an MPLS network is a very quick protocol that generally runs on fiber optic cables. And it stands for multi-protocol label switching. So it's a type of switching. Switching generally is very fast. Now, multi-point generic routing encapsulation, that occurs in VPN deployments. So I mentioned to you on our very first meeting last time, 2 days ago, it's already 11:45, I already mentioned to you that the purpose of VPNs were to create a completely encapsulated tunnel between 2 points to subvert the necessary going through each router and everything. It creates a logical, when I say logical, I mean virtual tunnel between source and destination before you actually make your request. So that is so nobody can run like Wireshark over your connection and see what it is you're doing. So that's VPN connection. So MGRE, think of it as multi-point VPN deployments. Peer-to-peer is when you decide whether or not you yourself want to join a protocol, okay, and you decide whether or not you want to be client or server. Client server is, as I said, the polar opposite, because client server is that only one device runs everything, and everything else is their client. An example of peer-to-peer would be a Microsoft Workgroup. An example of client server would be the Active Directory, Microsoft Active Directory. So the advantage of Active Directory is that it is way more complex and more suitable for being scaled upwards. So you're talking scalability. So the difference is that with a web server like Apache, if you've ever installed a LAMP, Apache is the A in LAMP. L, of course, is Linux, and M is the SQL, and P could be Python or PHP. The Apache allows you to install web server software on your host, whether it's your laptop or a standalone PC or something, and you can then project your IP address to that's called host routing. So you can route your host to the internet, and then you can serve out your web page. So you're a server, and everyone in the rest of the world that can get to you is now your client. So that is client server because it's scalable. And it's easier to maintain because if there's an issue with the web page, you don't look at any of the clients, you only have to work on the server. Physical networking topologies. We have the bus topology, and we'll talk more about the bus topology, what that is next time. But just know I'm on figure 1.9 on page 100, and then we have the printer, client, server, all connected to the same bus. That is the traditional Ethernet topology. This is what Robert Metcalfe created. Now, keep in mind, he created it in 1979. So we didn't have like everyone and their kids online all the time. Okay, star topology is almost like the topology of IBM, but we can see that it looks like a bike wheel. Okay, see that? And there's one device that controls everything. Okay, the advantages is new stations can be added or removed easily and quickly. A single cable failure won't bring down the entire network. It's relatively easy to troubleshoot. Ring topology is, well, actually, the star topology is kind of like the Ethernet. The IBM technology is kind of like the ring topology in Figure 1.11 on page 106. That's the ring topology. And at IBM, they called it the token ring. And we'll talk more about that on Tuesday. Mesh topology offers a lot of fault tolerance. Okay? It really does. Because look at it. You have all those redundant connections. See that? So in other words, if the connection between the two extreme switches goes down, you have all these other connections that can take over. Now, I'm on Figure 112 on page 108, 1.12. Now, the thing that manages those redundant connections, because it's layer 2, is what we call spanning tree protocol on layer 2. Okay, so point-to-point topology, I'm on Figure 1.13 on page 110. We have a serial connection. Serial connections are only about 45, well, they're very slow. Their T1 speeds are very slow. Direct Ethernet or wireless, when it comes to Ethernet, they just call it a point-to-point connection. If they connect via wirelessly, that's called an ad hoc connection. Okay. And we have point-to-point methodology right here. We have point-to-multi-point methodology right here, in which you have the corporate office. Now, the advantage of this is that you have one corporate office, and the corporate office can connect to any one of the branch offices on the left-hand side right here. But the branch offices cannot connect to each other. You see that? So the corporate office can contain PII, or they can contain certain things that they don't want anyone to know about. And then branch offices, they have their own PII, but they cannot share with each other, as you can see. I'm on Figure 114 on page 112. Okay, now I'd like to, because it's 1152, let's talk about the network backbone on Figure 117 on page 117. So this illustrates a network and shows which part of the backbone and which parts are segments. So the backbone connects everything together, as you can see. And technically, we have different segments here. Okay, so we have the marketing segment, the server segment, sales segment, and host segment. It's really throwing these terms around, and I don't think they're being used properly, but it is what it is. But that's the backbone right there. All right, and let's look at the three-tier model. Figure 118 on page 121. So the three-tier model is really pushed by Cisco because they want a separation or hierarchy of duties for these devices. And man, I wish I had more time with you. The core layer, let's work bottom up. Access layer is easiest to visualize because anytime, like in 131 or at least in 156 in SIL, a lot of times during class, it's got that printer right there, and the printer's connected to like a switch. because we can see and touch that switch, chances are that's on the access layer. Okay? The next layer up from that is the distribution layer. The distribution layer, as you can see, connects the core to the access. Usually the distribution layer has a lot of interconnecting, redundant connections with each other. And the distribution layer works out the security policy. So at the distribution layer are all the virtual LANs. So the virtual LANs are when you actually logically segment your network. So you know how it said marketing and sales are separate? Why would you want to separate marketing and sales? Well, marketing, for one, tends to exist in a traditional network form. Sales, on the other hand, tend to do things more remotely. So there is a different risk surface or risk pattern with sales. So you wouldn't want them on the same segment. So you'd want to divvy them out. So this happens through the creation of VLANs and other things at the distribution layer. The core layer simply connects you to the next layer, to the internet, essentially. So you're looking at the core layer. The core layer has to do with speed, okay? The distribution layer, that has to do with intelligence and making decisions and logically segregating your network. An access layer is the layer that us, the people that work with your equipment, can touch. So it's just where you can plug into that layer 2 switch. That's the access layer. And then the access layer is going to connect to more powerful switches on the next layer, because that next layer, they have to be more powerful switches because they have to make decisions. And then the core layer, that's going to connect to the ISPs. So they're going to be they don't have to be as beefy as the distribution layer, but they're going to be beefier definitely than the access layer, because they need to basically forward a lot of packets and a lot of traffic, because they're going to be connecting directly to the ISP. Okay, finally, we're at the end here. Now we have let's talk about traffic flow, figure 120 on page 125. Okay, we can see the difference. North-south, we'll start with north-south. South is like your internal network. Okay, and as you go from your internal network to the internet, that's north-south. East-west is the fact that most enterprise environments not only have the capital I network, capital I internet. The capital I internet is the actual internet. It's an internet we go to get to Facebook, to get to our Amazon, to get to Alibaba, to get to EMU, emish.edu even, right? But there's another lowercase internet, and that's our local data center. That's where we might have, that's the on the right, the server farm. That's our local internet. So when we want to go from our local internet to anywhere internally, that's east-west. If we want to get to anything internally to the internet, that's north-south. Does that make sense? So taking a look at figure 120, to get from our private data center to our corporate internal network, is that east-west or north-south? That's east-west. To get from server farm to the internet, is that east-west or north-south?
North-south.
North-south. Very good. Well, that's it. That's it, because I gotta go. I mean, Google Meet's gonna end any second, so I hope this was enriching for everyone. And the good thing is this is recorded for posterity. So if you want to look at this later, feel free. Now, moving forward, I'm just gonna I might put a little bit of homework for this for tonight or for this weekend. So by tomorrow night, I should upload some homework. And, I'll have a tutorial about how to get to your packet tracer.
All right.
When will the homework be due?
Next Sunday. Not this Sunday. Next Sunday. That make sense?
Yeah, that makes sense.
What is it on the the topics today and the topics on Tuesday. Next Tuesday. This coming Tuesday. This coming whatever. So the homework wouldn't be due in 3 days, it would be due in like 10 days. Anyways, okay then. Everyone have a good rest of the day and be safe and do good. I'll see you later.
Thank you.
Yes,
Professor. See
James,
you.
did you have a question?
Bye.
No, that was a peace sign.
Oh, peace. I didn't see that because the light was reflected. All right. You have a good one. Bye-bye.
You too.